All right. So, and we're back, everybody. So, as I was kind of explaining here, we have 2 more sections to do before we have our Chapter 6 test. We've got Section 6.3. You'll notice as I pass out the guided notes that it says 6.3 day 1. We're going to spend 2 days on Section 6.3. We're going to spend 1 day on Section 6.4. That means we're going to take Friday, Monday as Section 6.3, Tuesday as Section 6.4, Wednesday as the practice test review, Thursday we're going over our practice test. Next Friday, a week from today, we'll be taking our Chapter 6 test. Okay?
Well, with it. Really clean out your ears. Thank you.
Yes, we will review the next following Monday, Tuesday, and Wednesday before our exam.
I was just making sure people aren't buying it.
Oh, got it. Thank you. Yes. But just clarifying for those people playing along at home on the live stream.
It's formative, right?
See, that's the funny part. People are like, oh, what is it? Is it formative? Is it summative? Is it going against my 9 weeks grade? It's a whole completely different thing. It does not affect your 9 weeks grade. It is a separate grade. Like, if you think about the calculation for your final grade, like your overall year grade for Algebra 1, it's 10%. You know, here's your, let me get a new page. Here's your first 9 weeks. We'll call it MP, marking period 1. Here's marking period 2. Here's your first exam, semester exam. Here's your marking period 3. Here's your marking period 4. And here's your final exam, right? You have those 6 grades, okay? This is 20%. This is 20%. This is 10%. This is 20%. This is 20%. This is 10%. Okay? So your semester exam does not have any effect on your marking period 2 grade. The only thing it calculates into is your final grade for Algebra 1. Okay? Notice 2020, 10, 2020, 10, all equal 100%. Yeah? So it's not summative, it's not formative, it's its own thing. It's 10% of your overall grade. Yeah? Okay, so exams are extremely important. 1 test is worth half of what a 9 weeks is worth. 1 test is worth 4.5 weeks worth of work. Plan accordingly. Okay. All right, so Section 6.3 is still solving systems. Okay, we are still solving systems. What does it mean to solve a system? What is the solution to a system? If I think about it graphically, what is the solution to a system? Visually. People, listen to me. Come on, wake up. What is the solution to a system? Like, what are you writing on your answer blanks? Come on now.
A coordinate.
A coordinate, thank you. It's a location where the 2 lines will cross. So don't lose sight of the end goal that if I want to find the solution to a system, you're looking for where the 2 lines will cross. Now, we talked about it by way of graphing. You know, obviously, if I just want to figure out where the 2 lines will cross, we'll just figure out where they connect, right? Does that always work? Not necessarily. What happens if they cross at a weird spot? All right? Okay, well, then we talked about substitution. Substitution will always work, but sometimes it's more difficult than others, okay? Now we're going to talk about what's called elimination. Now, elimination is like we can either choose to do substitution or elimination if I want to solve it algebraically. Like if I don't want to use my graph, I can either use substitution or elimination. It's just kind of like sometimes it's easier to do substitution, sometimes it's easier to do elimination. And what we're going to do within these next couple of days is decide when it's easier to use elimination after we figure out what it is. Now, instead of me telling you, like obviously there's no steps to doing elimination on your guys' notes here. Instead of me telling you how to do it, I think it might just be easier to show you how to do it. So let's take a look at this first example. This says solve by elimination. Now, the name of the thing is kind of like telling you, okay, one variable is going to eliminate. Something is going to eliminate. What does that word eliminate mean? What does eliminate mean? To take away, right? To go away. So one of the variables is going to eliminate. One of the variables is going to go away. Watch what I can do here. What if I just try to add those two equations together? Because obviously I could do that. I have the same, I have 3x minus 4y equals 10. I've got something equivalent, and as long as I add something equivalent to both sides of the equation, that's still okay. So if I'm going to add x plus 4y to the left side, I'll add negative 2 to the right side. Now what happens if I just add straight down? What's 3x plus 4x? Or 3x plus 1x is 4x. Whoops. What's negative 4y plus 4y? It's not y. It goes away. Right? We could write 0. But why would we? 0y would make it go away. So it's just gone. It has eliminated. What's 10 plus negative 2? And look at the equation that we got. How do I solve that equation? Divide by 4. Okay. So that means x is equal to 2. Now, at this point, this turns back into the same thing that we would do for substitution. At this point, once you have one of the variables, you can come over here and start to create your answer. And then you say, well, what's my other solution then? What's my other value? How do you find the other thing? Once you've got one, how do you find the other? Yeah, which one do you want to put it into? Okay, let's put it into the bottom one. So x is 2, so it's 2 plus 4y equals negative 4. Right? All I did was take this equation, equation 2. Oh, what the heck? Where did I get negative 4 from? Maybe here. That's weird. I'm losing it, folks. All I did was take equation 2 and I plugged in 2 because x is 2. And now we just solve. Oh, I know what I was thinking. I was already thinking of subtracting the 2. So 4y is equal to negative 4. Y is negative 1. I know. Hold on a second. Let me just bring down my answer here. So my answer is 2 comma negative 1. What's wrong, baby? Okay, so let's analyze why. Okay, I hope we would agree that was not so bad, right?
It wasn't terrible.
That wasn't terrible.
as bad as substitution.
Wait, what did you say?
It wasn't as bad as substitution.
Wasn't as bad as substitution, right? Now, a lot of people are going to like elimination better. The only reason why you're liking elimination right now is because it was already set up to eliminate. How did I know? Let's talk about that. What made this problem really easy?
Everything was lined up. Because 3x and x were lined up with 4y, and 4y were lined up.
Everything is lined up. What form are these both in? These are both in what kind of form? Standard form, right? X, Y, constant. So what was unique about the Y values that made them go away? Right. They were the same. Are they exactly the same? They're just opposites, right? Negative 4, positive 4. They were the same value, but with different signs. Okay. So let me tell you this. This problem was what I call set up for elimination because I had everything in standard form, and one of the variables had opposite coefficients. -4, +4. And when we put those together, it goes away. Okay? That's what I call setup for elimination. Let me ask you this. Is this set up for elimination?
Yes.
Yes. Are they lined up? X, Y, number?
Yes.
Yeah. What do you notice about the X's?
They cancel each other out.
Yeah, look, I've got a +2 and a -2. This is set up for elimination. Oh man, and that's really easy. Let's just add these two equations together. +2x and a -2x, eliminate. They cancel. What's a 1y and a 3y? 4y. What's a 25 and a -13? 12. And that creates us a really easy one-step equation to solve. We divide by 4 to both sides, so y is 3. So I come over here and I say, okay, it's something, comma 3. We just have to decide now what equation to plug it into. Which one do you want to do?
The first one.
Okay, let's plug it into equation 1. So it's 2x plus y, which is 3, is equal to 25. We subtract the 3 over to the other side. So we say 2x is 22. We divide by 2. X is 11. Could I have solved this by substitution? Sure. I mean, I would look up at the top and I would see, oh, look, y is alone. I'll take y, I'll subtract the 2x, that's 25 minus 2x. I'll plug it in for y, I've got to distribute it to 3, and then I'll resolve. I hope we would all agree that that would take a lot more steps to solve by substitution rather than what we just did with elimination. Okay? Let me ask you this. Is this set up for elimination? No. No. It almost looks like it is. Because everything, box check 1. Everything is lined up. Everything is in standard form. X, Y, constant, good. I see the same number on the X, but do they have opposite signs? No. If I added them together, what would I get? Would I get a 0? X? No, I'd get a 4x. Okay, so maybe there's something I can do about this. Maybe there's something I can turn that one of those +2's into a -2. Watch here. What's wrong?
Take the negative away from the after you
No. Watch what I could do. I am going to take all of equation 1. If I want 2 to be negative, I would multiply it by a -1, right? But I can't just pick and choose which variables I want to do. I've got to multiply the entire equation by -1. Okay? You cannot just pick and choose which variable you want to use. You want to multiply by. You've got to do the entire equation if you're going to multiply. So what does that mean? That means this turns into a -2x, a -y, and a +5. Now, I don't want to touch the second equation. The second equation is fine as it is. So leave it. +2x minus 5y is equal to +13. And now I can add down. Why don't you guys finish that off for me? What's wrong?
Isn't that y? I'm saying.
That's okay. You can, the y's, it doesn't matter, just as long as the x's head opposite. Because you want the x's to go away. You want the y's to stay there so you can solve for it.
I couldn't breathe before.
They snap their back in half. People feed too much. Literally, their back goes to their head. They can't do anything about it. They would start walking around with a little hump and nobody would notice. It looked decent. And then when they go to walk, they'll just kind of do this squirm thing. Like it happened to one of my numbers. Yeah, basically all we did was, well, what's that? Oh, and then we went over to the veterinary place or whatever. All we did was, you know what? We really can't do anything about it. We gotta put it down. Or we can do this weird thing where you got this like ring.
I've never been a product
before, and then we just kind of hope that back decided to go back together, and it did eventually. And then he died. Yeah.
Okay, we're back. Okay. So I add down and I get, okay. I'm gonna make a rule. Phones are gone during my class. Like in your bag, not on your lap, not in your crotch, in your bag. Let's go. I will take it from you and not give it back to you until the end of the day, until the next day. I don't care. I'll be mean. I'll be really mean. Okay, it's really ticking me off. Not on your desk, no, in your bag. Okay, now we add down here. Okay, we get negative y and a negative 5y, negative 6y, 5 and 13 get us 18. We divide by negative 6, I get a negative 3. Okay. Plug y back in. Now, which one do we want to go in for? Liam, you pick. Okay, so we got 2x. Now, instead of putting plus a negative 3, I'm just going to write minus 3. We add the 3 over to the other side. So we get a 2x is equal to negative 2. We divide by 2. X is negative 1. Yeah.
When we do the simplified one, the one that we times by negative 1.
It doesn't matter. You could if you wanted to.
Well,
I like to go back into one of my originals because usually that causes less mistakes.
the answer is different.
It shouldn't be. So you put it back into here?
Yeah.
Okay, so that means you should have gotten a negative 2 minus a negative 3. Or sorry, negative 2x minus a negative 3 is equal to 5. That should have been a plus 3 then. Subtract the 3. And then divide by negative 2. So x is negative 1.
Was that the?
Hold on a sec. Does that make sense?
Oh, because you turned the.
Yeah. You've got to do the minus the negative. Yeah. Liam, question?
Was it supposed to be a minus 3 on the equation that you just did?
Here?
Yeah.
Yeah.
So like below it, like you added
No.
to the other side.
No. I got to do inverse operations. This was a minus 3.
Like on the with the negative 5 plus negative 3.
No, it's negative 5 plus 3.
Oh, so you cancel it. All right.
Yeah, because this was 2x plus a negative 3. Would we ever write plus a negative? No, you'd write it as a minus. All right, let's keep it going. Okay, so is this set up? No. I can check the box that says they're both in standard form, but I can't check the box that says they have the same number but opposite signs. Okay, so there's really two options here. I could either make the x's the same or make the y's the same. It doesn't matter what you choose. In this case, they're both kind of easy to do. Let's take, for example, the x. What should x be to make this eliminate nicely? What should the coefficient on x be to make this eliminate nicely?
3x.
Positive 3, right? If this was just a positive 3, then I could add down and x would go away. So I need to multiply the x by positive 3. So that means I'm going to multiply the entire equation by positive 3. You can do this. You are allowed to do this because whatever you do to one side, you just have to do that same thing to the other side. If I multiply the whole left side, I just got to multiply the whole right side. Okay, so that means my top equation is going to become 3x plus 6y is equal to 33. You've got to multiply the entire equation, not just pieces and parts. The bottom equation remains exactly the same as it is. Negative 3x plus y, negative 5. Now I can add down. Now this will eliminate. Take a look at what happens to my x's. My x's will completely cancel. My y's, I add together. 6y and 1y will get me 7y. 33 and negative 5 get me 28. I divide by 7, so y is 4. Okay, and now at this point, I can go back into either one of my originals or one of my multiplied equations. Doesn't matter. I could go into any equation and plug in 4 for y. So which equation do we want to do? Top one. So we've got x plus 2 times 4 is 11. Well, that means x plus 8 is 11. Subtract the 8. So x is 3. So that means it's 3 comma 4. That's my answer. Now remember, you're looking for the coordinate where they cross, right? Give me a coordinate. Okay, let me ask you this. What if I wanted to eliminate the y values? What if I wanted to restart this problem? What if I had chose from the very beginning to eliminate my y values? Go back to the beginning and say, okay, what do I have to make as my y value? Negative 2. I need to make my y value negative 2, which would mean I would multiply the entire bottom equation with negative 2. I would leave my top the same, but multiply my bottom equation by negative 2. Okay? All right, let's take a look at, is this? Yeah, this is your last one? Yeah. X plus 2y is equal to negative 1. 4x minus 4y is positive 1. Okay. Do you see how my x coordinate, or sorry, my x coefficient, my x is alone on the top? Usually, that's the easiest thing to multiply, to be able to eliminate. For example, what would we really love to have as my x coefficient on top? Negative 4, right? So that would mean I need to multiply my entire equation by -4. Okay? Multiply your entire top equation by -4. I want to give you guys a minute and try to see if you can do it on your own. But what you're going to do is you're going to multiply your entire top equation by -4. Know that you could have manipulated so you solve for y. Couldn't I try to get my y to be -4 on top? Or +4? Just multiply the top equation by 2. That would be okay too. Yeah.
I have a question. So can we divide by 2 on the bottom one?
You could, but I would hesitate to divide. Usually dividing can get a little weird.
Yeah.
So I would stick with multiplication. All right, so top equation becomes -4x minus 8y is equal to +4. You got to distribute that -4 all the way in. Everything gets multiplied by -4. Okay, now the bottom equation becomes a +4, or just stays, +4x minus 4y is equal to 20. And now, because my first terms are -4 and +4, my coefficients are -4 and +4, they will cancel each other out, leaving us with, I add the -8 and the -4 to make a -12, and then 20 and 4 make 24, which is a nice, easy equation to solve. Y is -2. Okay, I can go back in and solve for x now. Which equation do you want to go in? Keep telling me.
The top one.
The top one. Who wants to do the top one? Original top. So x plus 2 times -2 is -1. We plug -2 back in for y. So -2 and +2 make -4. I add the 4 over to the other side. X is 3. 3 comma -2. And that's my answer. Okay. So, the steps for elimination are this. Make sure it's in standard form. X, Y, constant. Make sure it's in standard form where the X's and the Y's and the constants are all lined up. Next thing you've got to look for is either a variable that's already set up for elimination, meaning it's the same value, just positive and negative, or one that you could force that into happening, right? Where we have just an x, where if I took that x and multiplied it by -4, it would eliminate with the x's, the other x. If I multiply one of them, I got to multiply the whole thing. So I multiply by that entire equation by -4. And then after that, that's when I can add the two equations together. Once you get one of the values, you plug it in to find the other. Okay? All right. I hope everybody's having a good weekend, or, well, I guess weekend if you're watching it later. But I hope everybody have a good weekend at home, and so long.